I will present about the preemptive priority. For the first, find the 0, define the process 10. 0 additional 1 is 1. Define the process 10. 1 additional 3 is 4. Define the process 3. 4 additional 1 is 5. Define the process 3. 5 additional 1 is 6. Define the process 3. 6 additional 1 is 7. Define the process 5. 7 additional 1 is 8. Define the process 5. 8 additional 8 is 16. Define the process 4. 16 additional 7 is 23. Define the process 10. 23 additional 2 is 25. Define the process 8. 25 additional 6 is 31. Define the process 7. 31 additional 2 is 33. Define the process 1. 33 additional 8 is 41. Define the process 6. 41 additional 9 is 15. Define the process 2. 15 additional 5 is 55. Define the process 9. For the last is 55 additional 4 is 59. Waiting time of process 1 is 33 minus 5 is 28. Process 2 is 15 minus 5 is 45. Process 4 is 16 minus 7 is 9. Process 5 is 7 minus 7 is 0. Process 6 is 41 minus 5 is 36. Process 7 is 31 minus x is 23. Process 8 is 25 minus 6 is 19. Process 9 is 55 minus 1 is 54. Process 10 is 0 minus 0. Addition 23 minus 4 is 19. Average waiting time is 28. Additional 45, additional 0, additional 9, additional 0, additional 36, additional 23, additional 19, additional 55, additional 19 is 233. Divide the 10 is 23.3 milliseconds.
Good evening to Mr. Bao. My name is Yap Chong Yi. For my part, I will show you how to do preemptive shorted job first. So, in 0 milliseconds, P10 has arrived. So, P10 is the only process, so it will be executed by the CPU. After executed by the CPU, the next arrival time will be 1 millisecond, and then P9 has arrived. Then we have to see which one has the shorter burst time, and the remaining time for the P10 is 5. So, P9 will be executed. Why? Because it has the shorter burst time. After execute P9, the next arrival time will be 4 milliseconds. In 4 milliseconds, P3 has arrived. So after P3 has arrived, we execute P9. After execute P9, the next arrival time will be 5 milliseconds. And for 5 milliseconds, there are 5 milliseconds in the arrival time. So I have to select 3 of the process from the 5 milliseconds and put it as a arrival time, which are P2, P1, and P6. So after these 3 processes has arrived, we execute P3. After execute P3, the next arrival time will be 6 milliseconds. In 6 milliseconds, P8 has arrived. So after P8 has arrived, then we execute P3. After execute P3, the next arrival time will be 7 milliseconds. In 7 milliseconds, there are 2 in the arrival time. So we have to select both the process and put it as a arrival time. So P4 and P5 will be the arrival time. After both the process arrive, then we execute the P3. After execute P3, the next arrival time will be 8 milliseconds. And in 8 milliseconds, P7 has arrived. So after P7 has arrived, we execute it. Why? Because it has the shorter burst time. So after 8 milliseconds, there are no more arrival time. So we can just let the process to be execute. So once the time should be stopped here, which is 10. How I get 10? I use 8 plus 2, which will get 10. So by 10 milliseconds, P10 will be finished the execution. So after that, by 15 milliseconds, P2 will finish the execution. By 20 milliseconds, P8 will finish the execution. By 26 and P4 will finish the execution, and by 33 P1 will finish the execution. By 41 P6 will finish the execution, and lastly by 50 P5 will finish the execution, and the final result will get 59, which means that P5 is the last one process be executed. Why? Because P5 has the longest burst time. So after that, for waiting time, the formula will be response times minus with the arrival time, which means that P1, we get the response time from the P1, which is here, 33 minus with the arrival time, which is here. Then we will get the waiting time, which is 28. After we calculate all the process, and then we just total up all the final result and divided by 10. Why? Because we got 10 process, so divided by 10. After divided by 10, we will get the average time, which is 16 milliseconds. And that's all from me. Thank you.
Good morning, sir. My name is Jeessey Xing. I would like to present question 2 about schedule reading algorithm. My part is now creating shorter job first. Consistent the following 10 process, each having its burst time and arrival time. First, which one follow the arrival time, which one is 0. Processing is 0 means processing is already executed. So the processing is the first one. Then the burst time of processing is 13, so 0 plus 13 equal to 13. Next, confirm all the process burst time are already in 13, so all the process are already in 13. So the next is choose the shorter burst time. Because the question is shorter job first, so the more shorter is 3. So the second is process A. Then is 13 plus 3 is equal to 16. Then the next is 4. So the next is process 7. So it is 16 plus 4 is equal to 20. Then the next is 5. So the next is process 9. 20 plus 5 is equal to 25. Then the next is 6. But the 6 has 2 process. It is process 2 and process 4. So we must show the which one arrival time is more shorter. So it is process 4 because it is 9. Then the process 2 is 10. So the more shorter is process 4. So the next is process 4. 25 plus 6 is 31. Then the next is process 2. 31 plus 6 is 37. Then the next burst time is 7. So the next is process 3. Process 3 plus 7 is 44. Then the next is 9. So process 1. 44 plus 9 is 3. Then the next burst time is 10. So it is process 10. 53 plus 10 is 3. Then the last is 11. So the last executed process is in process 5. So 3 plus 11 is 4. Then the next with my calculator is waiting time. First is process 1. Process 1, 44 minus the arrival time is 6. So 44 minus 6 is 38. Then the process 2, it is 31. Then the arrival time is 10. So it is 31 minus 10 is 21. Then the process 3 is 37 minus 3. So it is 34. Then process 4 is 25 minus 9. So all the process is the same. Then the last is calculate the average waiting times. So it is 38 plus 21 plus 34 plus 16 plus 15 plus 0 plus 10 plus 7 plus 16 plus 44. Then divide 10. So it is equal 33.6 ms. That's all for me. Thank you, sir.
Good evening to Mr. Palpulai. My name is Wendy Tan Wei Wei, and now I would like to explain about how to solve scheduling algorithm using round robin with quantum equal to 6. So first, you must follow all the steps here. You must determine the interval. So first, we must look at which process arrived first. The first process arrived is P6, and with burst time 13. So the burst time 13 is bigger than the quantum 6. Therefore, from the arrival time 0, we add 6. Next, we list down the arrival time, the arrival of processes. So within 6 milliseconds, which process arrived? We have process 3 arrive, process 9 arrive, and then followed by we have 3 processes that arrive at the same time, which is 6 milliseconds. So whenever the arrival time is the same, we must first write down who has the shorter burst time. So between first process 1, process 7, and process 8, we have the shorter burst time is process 8, followed by process 7, and then only process 1. Therefore, we write out all the process and the burst time here. Then we execute the process. The first process to be executed is process 6. Therefore, process 6 is being executed, and the burst time 13 minus 6, we have the remaining burst time is 7. Therefore, we write down here. Then we repeat all the steps again. Determine the interval. Burst time 7. 7 is bigger than 6. Therefore, 6 plus 6, we get 12. And then list down the arrival process. The process arrives between 12 milliseconds. We have P4, P10, and P2. So P4 and P10 arrive at the same time. P4 has the shorter burst time. So P4 write down first, followed by P10, then only P2. Next, execute the process. P3 is the next process to be executed. So the remaining burst time for P3 we write down is 1. 7 minus 6 is 1. Then continue. Again, determine the interval. The next burst time is 5. 5 is smaller than burst time 6. Therefore, instead of adding 6, we add 5. We add the burst time. So 12 plus 5, we get 17. And then list the arrival processes that arrive between 17 milliseconds. We have the last processes, which is P5. So we write down here P5, it is burst time. Then the steps later on, we don't need to list down the arrival processes as all the processes have already arrived. Next, we have to execute the process, which is P9. So for P9, there is no remaining burst time. And then we continue to execute P8. So the interval to be determined, 3 is smaller than the quantum 6. Therefore, we add 3 rather than add 6. So 17 plus 3 will get 20. So follow all the steps here. We execute P7 and then no remaining. P1, we have the remaining burst time. 9 minus 6 we get is remaining 3 burst time. And then continue execute P6. We have remaining burst time 1. Execute P4. No remaining. Execute P10, have remaining burst time 4 milliseconds. And then P2, 6 burst time, so no remaining. Continue P3, no remaining. P5 have remainder 5 milliseconds. So after executing all these processes, we will finally stop at the process 5, and the total burst time will get at 74. So how to calculate waiting time is, we first look at when the process starts to execute. So for P1, the process starting executing at 24. So 24 we minus the arrival time for process 1 is 6. So 24 minus 6. And then we plus the first execution of P1 is 30. Then is continue at 61. So 61 minus 30 So this calculation will get answer 49. So for P2 also the same. The P2 started to be executing at 48. So 48 minus the arrival time, 10. So 48 minus 10, we get 38. So for P3 until P10, also the same step. So for calculating the average waiting time, we add on all the waiting time and then divide by the number of processes. So the final answer we get is 34.4 milliseconds. I think that's all from me. Thank you.